Hey there, last time we were talking about quadratic equations and I had said that we'll talk about another interesting method to solve these quadratic equations. So here's a simple one, x square minus 16 equal to 0. So if this is the quadratic equation, it's pretty simple to solve. Let's see how. We just move the 16 to the right hand side, we would have x square equal to 16. That means x would be equal to plus minus under root 16 or plus minus 4. So x is either equal to 4 or negative 4. This is a solution. Pretty simple, isn't it? Let's look at a little more difficult one. So if we have x plus 2 whole square minus 16 equal to 0. So this would be x plus 2 whole square equal to 16, or I can say x plus 2 is equal to plus minus 4 as we saw here, and then x is either equal to plus 4 minus 2 or x is equal to negative 4 minus 2. That means x is either equal to positive 2 or x is equal to negative 6. These are the two solutions. Let's look at a third equation. 2x plus 3 whole square minus 16 equal to 0. Now here again we would have 2x plus 3 whole square is equal to 16 or 2x plus 3 is equal to plus minus 4. This would give us 2x is equal to plus 4 minus 3, that is 1, or 2x is equal to negative 4 minus 3 equal to negative 7, which gives us x is equal to 1 by 2 or x is equal to negative 7 by 2. Now let's look at a third equation. So here's the equation, 4x square plus 12x minus 7 equal to 0. The answers are x equal to 1 by 2 or x equal to minus 7 by 2. You must be wondering, how did I do it that fast? It wasn't a trick. If we look carefully, the equation that we had just seen before this one, is nothing but the same as this equation. Just expand 2x plus 3 whole square and we would have 2x whole square plus 2 times 2x into 3 plus 3 square minus 16 equal to 0. This would be 4x square plus 12x. This would be plus 9 and minus 16 or minus 7. That is the same equation as this. So if we are given such an equation, we don't always need to go by splitting the middle term method. We can always convert any equation in this form. And it's so simple to solve that it doesn't take much time. So why not we convert every equation of this form into equations in the form of this, where we have a complete square in terms of a linear expression of x and a constant term. Now this method is called completing the square method. And once we get a hang of this, it's very simple to solve. Now let us just consider this equation itself. So this is 4x square plus 12x minus 7 is equal to 0. Now we have to convert this equation in the form of, let's say, an mx plus c whole square minus n equal to 0. Now here, if you look carefully, this is a linear expression in x whole square and minus n equal to 0. Now we just have to find out the values of m, c and n. Now let me just expand this one. So I would have m square x square plus 2 times mx into c plus c square minus n equal to 0. Correct? So this is nothing but the coefficient of x square is m square plus 2mc into x plus c square minus n equal to 0. So the terms in the brackets are the coefficients of x square, x, and the constant term. So we just have to equate these coefficients to the coefficients of the equation that is given to us, and we can just find out the values of m, c, and n. So the first thing to do is just equate the coefficient of x square with that of x square here, that is m square. So here m square is equal to 4, correct, or m is equal to 2. We just consider the positive value right for now. So we have m equal to 2. Now when we have m, we have to find out c. So we know 2mc is equal to 12 from here, and we know m is equal to 2. So 4 into c is equal to 12, or I can say c is equal to 3. So if I use this value of c here, then I would have 3 square, that is 9, minus n equal to negative 7, because it's negative 7 here. So I would have n is equal to 9 plus 7, or n equal to 16. So I can use these values of m, c, and n in this expression, and this equation would in turn become 2x plus c would be 3 whole square minus, because I had used minus here, and n, the value of n is 16, is equal to 0. So this equation 4x square plus 12x minus 7 equal to 0 turns into 2x plus 3 whole square minus 16 equal to 0. And we just saw how to solve this here, and the solutions were x equal to half and x equal to minus 7 by 2. Now this is the completing the square method. We'll look at another example to make it easier for us to understand. And this time we won't be using this. This is just for our reference. We'll do it mentally. So let me write the equation. The equation is 5x square minus 6x minus 2 is equal to 0. Now this is the equation that is given to us. Now if you remember, to complete this square, we need the coefficient of x square to be a perfect square as well. So how do we make sure that the coefficient of x square in this equation is a perfect square? Now there are two ways of doing it. Either I can divide this whole equation by 5. That would give me 5x square by 5 minus 6x by 5 minus 2 by 5 equal to 0 by 5. Now in this case, this 5 and 5 would get cancelled, and this equation would in turn become x square minus 6 by 5x minus 2 by 5 equal to 0. Now if you look carefully, here the coefficient of x square is 1, which is a perfect square, and now I can use that method of completing the square. But there will be some complications because I have fractions as the coefficient of x and as a constant. So there's another method of doing this. If I have to convert the coefficient of x square in this equation to a perfect square, I can multiply the whole equation by 5. So this was dividing by 5. Now in the next method, I want to multiply the whole equation by 5, and I would get 5 into 5 x square minus 6 into 5x minus 2 into 5 equal to 0 times 5. Remember to multiply or divide the full equation by 5. So I would have 25x square. See, it's a perfect square. Minus 30x minus 10 equal to 0. So this is the equation that I have to solve. And it's nothing but same as this one. Just that the coefficient of x square here is a perfect square. So let me just try to solve this equation now. So the equation is 5x whole square. I'm just writing 25x square as 5x whole square minus 30x minus 10 equal to 0. Now here I have the first term, that is 5x whole square. I need to convert this minus 30x such that it forms the middle term of the expansion of mx plus c whole square. So this was m square x square, that is the first term. The middle term was plus 2mcx. The middle term is always the one with x to the power 1. And minus 30 should be equal to plus 2mc. And then the constant term was c square minus n. So here I would have 5x whole square minus, now this minus sign represents that c here would be negative. So I have minus, and 2 is always there in the middle term, so I'll pull out 2. Inside I would have 15x remaining. M here is 5, so I would have into 5, and I have x here, so the remaining would be c. This is minus 10, so c would be 3. So this is 3, and I would have 3 square added to it, and I will just subtract 3 square so that I have the balance intact. And then minus 10, as was always there, is equal to 0. So this is my equation. This equation has just been converted into this one, where I have just added 3 square and I have subtracted 3 square. Now if we look at the first 3 terms, these, they are of the form a square minus 2ab plus b square, which is nothing but a minus b whole square. Here a is 5x and b is 3. So I can easily write this equation, the given one, 5x square minus 30x minus 10 equal to 0, as 5x minus 3 whole square minus 3 square minus 10 equal to 0. Now this would become 5x minus 3 whole square minus 19 equal to 0, or 5x minus 3 equal to under root 19, positive or negative. And it's very simple from here. So I would have x is equal to 3 plus minus under root 19 by 5. So these are the two solutions for x for the equation, this one, 5x square minus 6x minus 2 equal to 0. And we can always verify them. How do you verify these? Just put the values of x that we have found out into this equation, the left hand side of this equation, and if it comes out to be equal to 0, we have verified that those are actually the solutions for this particular equation. We'll look at more examples in the next video. Bye.